Hello again. Right, on this occasion I'm now going to do a series of videos on repairing and debugging a totally different board that I've now acquired. This is actually a Scramble bootleg set of boards, and unfortunately in its past life somebody's tried to convert it into Super Cobra, but they've done it in a sort of a rather rough way because they haven't used the 4K EPROMs that should have been used on the original Super Cobra board. Now the Super Cobra board and the Scramble board are more or less the same. There are some differences, but this board is actually a Scramble board, or was originally. So my intention with this is to try and repair it and then convert it back into a Scramble board set, which is something that I always wanted anyway. So as you can see, this is the board on the desk. Now I've actually got the Z80 unplugged and I've got my tester plugged into it. It is a Z80 board again. And as you can see, there's all sorts of things going on here. There's EPROMs stacked on top of other EPROMs. There's green wires all over the place, which are the select lines for the other EPROMs. There's wire ads here, there and everywhere. The thing has been basically butchered a little bit. It's all correctable, but at the moment it doesn't work. So the board, I've powered it all up, and there is another board to it which you can just see over there. Ignore all the rubbish in the background because my desk is a mess. I'm not going to star much in this at the moment because I think it's more important to actually show you the actual boards and what's going on. This board's upside down because the way it works, it's linked by the ribbon and it's flipped upside down. But this board has another Z80 and a couple of sound chips, etc. This is really the sound board, etc. So we won't bother with all that. So the board is powered up, and as you can see, what we get on the screen, if you look at it, is that. Not a lot happening. Now the important thing with this is it actually does show all the colours and characters. So as you can see, we are getting something on the display. So the video circuit does seem to work. So the first impressions are this board is not booting up, but the video circuit is working, but it's just not getting anything from the processor, etc. So I think the first thing we'll do is we'll actually go back onto my test screen and we'll start and interrogate it if I can get my camera sitting right. It's not the best and this thing keeps moving, but anyway, let's try. So I'm going to have to go back. Ignore this for a second, it's just my monitor has a bit of a peculiar way of changing over to different inputs. And there we go, we're back up into the tester screen. Now if I can just sort this out a little bit better, hopefully you can see that. What I'm going to do is I'm going to open my test program. Now there are a few alterations to the test program. This is all in updates that will be on the website. But the first thing I'm going to do with this is I'm going to try and do something like read something simple like one of the EPROMs back. As you can see, my tester's now booted up, and if I can get this a bit closer, a bit focus hopefully, I can. Let's try and show this all working. Well, hopefully that's clear enough. Okay, so what we're going to do now is we're still a bit squint. Let's go straight. Hold on. That's a bit better. It's not the best, but it will have to do for the moment. There will be a series of videos, as I say, with this. This is the first one, so don't expect too much out of the first video. As we work our way through the board, obviously I'll do more videos. So the first thing I'm going to do is it's all ready to go. So the first thing is I'm going to try and read back some of the memory. So we're going to start at address 0. Z80 system, address 0 is usually the first area where the ROM starts. So we'll set 0 and then we'll set in, say, we'll just do FF. We'll get some data back for the moment and do a block read. Okay, it's read back something. Now, as you can see, it's all a bit odd. So for example, the first byte comes back to 1, and we've got 4 ones, and we've got 4 zeros, we've got 4 FCs, 4 C9s, 4 zeros, so there's something clearly wrong there because that doesn't make sense as far as Z80 code's concerned. And the fact it's blocks of 4, everything is blocks of 4, so as you can see it seems to be something going on. There's 72, there's 4 of those before it goes to 4 7Ds and 4 22s, so something's very odd there. Now I have actually already taken one of these EPROMs out of the board. They're 2716 EPROMs, and I've taken the very first one off the board and I've put it into a mini pro EPROM programmer, and I've actually read back the code out of the EPROM, and I do know for a fact that the code is alright in the EEPROM. So the first byte should have been EC, I think, if I remember rightly, and then it goes to something else, which is obviously what you expect. You expect sort of different numbers coming back all the time. So the fact it's doing this is a bit peculiar. So straight away there's an issue with reading data back. And now this could be part of the reason why it's not booting up, because if the processor is not getting the information from the EEPROMs correctly and it's coming back with this, it's not going to do anything. It will just sit in a loop, it will just not do anything, probably even hang up. So there is an issue with that. So we need to look at that first of all. Now the other thing I'm going to say, when you start doing work on a board, the first thing you want to do is, if I move this around, you want to get something like this. You want to print out schematics for the board you're working on, which is what I've actually already done. And I've actually printed out schematics for the Scramble board, not the Super Cobra, because it is a Scramble board effectively, even though it's been modded, it is actually a Scramble board underneath all the mods. And if I go to, obviously, the back page, you can see, hopefully there, that's the schematics for the board. And the Z80 is up there. This is where we're looking now. Looking at the schematics, all the data bus comes out of the Z80 and goes through two buffer chips, which are 8216. Now they're basically bidirectional quad buffer chips, which are selected by a select line, which is linked to the refresh and the memory request lines of the board. Now we don't do anything with the refresh line. The tester doesn't actually do anything with that. It's actually pulled high, but that shouldn't make any difference as long as the memory request line is toggled, and it is. And then down the bottom, the directions selected by effectively the read line, we should be able to control those buffers. So assuming the ROMs are correct, which are over here, and the processor is my tester now, there's nothing between the two of them that's the data is not getting through correctly. Now it could be a variety of things, but I think the first thing to look at would be these buffer chips. So what we'll do is the first video will just be this, and then the second video will be us looking at the data chips, the data buffer chips. Look at that. We'll then assert these lines here so we can get it into our right state, into the state we want it in, and we can take it from there. So this is really the first video on starting work with a Scramble board, which I thought would be a good idea, because I've been doing a lot on Pac-Man recently, but I thought it would be a good idea to actually start working on a different board. And this will be a good project because it is actually a bit of a mess, to be honest with you. So we'll see what we can do with that. So this is the first video, and I'll say the next video will be going straight in and looking at these buffer chips, and I'll show you how to do that. Okay, thanks a lot.